Hello everyone, and welcome to this video series where we will be going through grade 12 mathematics paper 1. This is from November 2018. Excuse me. So this is a bit of an older paper, about 6 years ago. As we can see, this paper is out of 150 marks and you have 3 hours. So basically you have 150 marks and 180 minutes. So you want to budget roughly 1 minute for 1 mark. What this does is it'll leave you with 30 minutes at the end to go back and double check your work, and to also in case you missed any questions, to go back and do those questions you may have skipped because they're difficult or anything like that. So this is just a general guide that I'll give for this paper. Try to work at a rate of 1 minute per mark. So if you see that a question has 3 marks, you don't want to spend more than 3 minutes on it. If you see yourself spending like 5 minutes plus on a 3-mark question, then it's a good idea to just cut your losses and leave the question. You'll circle back to it at the end of the paper, rather than wasting time, because there are like easier, like 1-mark questions littered throughout the paper, and you want to try and capitalize on making sure you get all of those low-hanging fruit questions in the bag before investing a lot of time into some of the harder questions. Okay. So just some information about the paper. I'm sure we're all familiar with this. The important takeaway is that we have 12 questions and we have to answer all of them, and we have to basically show all our working to get marks. And one thing that they don't tell you in the preamble here is that if you like start writing a question and then you realize you've made a mistake, and then you start beneath that question writing it the correct way, answering it the correct way, the examiners will always mark the first thing they see unless you have clearly canceled it out. So be sure that if you do like write a question, then you come back and revise your work and you realize you made a mistake, be sure to like very clearly indicate this is canceled out so that they don't mark it. Because if you don't, even if they see that the work underneath that question is the correct work, they won't mark that. They'll mark the first thing they see. Yeah, so that is one thing they don't tell you here. Unless the question tells you to, often everything must be given to 2 decimal places. That is some useful information as well. And of course we can use a calculator. Okay, so I'm sure we're all familiar with this. I'm sure our teachers have told us this. We all know what to expect when we write this paper at the end of the year. Yeah, so okay, we'll be looking at question 1 in this paper for this video. But the other thing I wanted to have a look at before we actually get into the question was just the data sheet we get. So we do get some useful information here, really. Some equations to do with interest. That's always good. They give us the quadratic equation. We have a series equation here. Sum equation as well. Sum to infinity. Here's sum to infinity. This is a geometric series. Yeah, they've given us a lot of things we need to know. Finding the derivative from first principles is also given. Difference of squares is given. Area of a circle is given. Equation of a circle. Some trigonometric functions as well. Some trig identities here. The double angle rule. So they've given us quite a bit, really. Yeah, they've given us quite a bit. We have standard deviation here as well. Some stuff to do with statistics. This looks like, again, to do with statistics. And yeah, okay. Area of a triangle, slope of a line, yeah. Equation of a line. Okay. So we know that this is what is there, yeah. It's good to just be familiar. So often what I'll do is in the exam, I'd actually just go to the back of the question paper, rip the formula sheet out, and then have it right next to me. So as I'm working through my questions, it's right next to me. I don't need to be wasting time flipping through back and forth to see it. Okay. All right. Okay, so now that we've just spent some time getting familiar with what are we doing here, let's have a look at the first question, question 1. So question 1 is 23 marks. So you probably want to spend about 25 minutes doing this question. If you spend less time, that's perfect. If you find yourself spending more time, like getting towards 30 minutes, especially like maybe with these longer questions, definitely cut your losses and try and move on. And then you'll circle back to it. At the end of the paper. Okay. Anyways, so the first question looks like we just have some algebra here. So they've given us a quadratic equation and they say solve for x. Okay, let me just rewrite the question. So we have x squared minus 4x plus 3 equals 0. Okay, so I think we can find some factors for this, yeah? So we need to find factors that when they add up, we're going to get negative 4. So factors of negative 4x, that when they add up, they're going to give us 4. And when we multiply them, we're going to get positive 3. So you can think about this. There's lots of different tricks of how to do this. Sometimes it's just easier to write down all the factors of 4 you can think of. So of course, negative 4 is a factor, 4 is a factor, negative 2, 2, negative 1, and 1. These are all factors of 4. So what factors can give us 3 when we add them? So when we oh yeah, my apologies. So we need to find factors of 3 that add up to give us 4. Yeah. Okay, so of 3, of course 3 is a factor of itself, negative 3, and then 1 and negative 1, I suppose. So when multiplying these numbers to give 3, and we have a negative here and a positive here, that means the factors that we choose for 3 both have to be negative, and there's only 2. Yeah, so it's an obvious choice, because negative 3 times negative 1 gives us positive 3, and negative 3 plus negative 1 gives us negative 4. Okay, so it's simple enough that we can just factor this. We don't have to use something like the quadratic formula. So we will just rewrite this as x minus 3. Doesn't matter what order you write it in. And x minus 1, yeah, equals 0. Okay, and we'll just equate each term to 0. One of them has to be 0, so x minus 3 equals 0, or x minus 1 equals 0. Okay, and then this tells us that x equals positive 3, or x equals 1. Okay, and that's the first question done. Yeah, okay, that's the first question. Okay, good. Okay, Second question. So here's a bit of a hint. They give us this little thing here. Now, if there was a way to factor this expression, they wouldn't tell us this correct to do decimal places thing. Obviously, here we're going to use the quadratic formula. Just looking at it, you can see, yeah, it's very difficult to come up with factors that multiply to give 1 and add or subtract to give -5. I mean, they probably do exist, but you're going to have to go into the complex realm, and that level of maths is much higher than anything we deal with in matric. So in this scenario, to get real solutions for this equation, we'll simply use the quadratic formula. And they gave us a hint by telling us correct to do decimal places. So I'll just rewrite the question. Okay, and of course, that's A, that's B, that's C, yeah? So they give us the quadratic formula in our formula sheet, but anyways, I will just rewrite it. So x equals -b plus or minus the root of b squared minus 4ac over 2a. Okay, now we just substitute our values in. So -b is -5 plus or minus root -5 squared minus 4. A is 5 and C is 1 over 2, 5. Yeah. Okay. All right. And then we can basically just figure out what's happening under the square root sign. So we have 5 times 1 just stays 5 times -4 is -20. -5 squared is 25. So 25 minus 20 is 5. So we have 5 left over under the square root sign. And in the denominator, 2 times 5 is 10. Okay. And then for -b, I mean, negative times a negative is positive. So we will have two expressions for x. We will have 5 plus root 5 over 10. And we will have 5 minus root 5 over 10. Okay. And the first one gives us 0.72, and the second one gives us 0.28. Okay. So at this point is when we would just use our calculator. Yeah. Okay. Very straightforward. Okay. All right, let's get rid of this. Yeah, I just need to charge my pencil. Let me just connect it real quick. Okay, back in business. All right. So we have an equality next. Okay. So equalities, there's a couple of different rules associated with equalities. Basically, your answer is going to be in the form of a range rather than a discrete value. That's the biggest difference. And also, if you have to luckily in this question, the right hand side of our equality is just 0. Yeah. But if we did have some terms on the right hand side and the left hand side, and we had to do some rearranging of the equation, there are some special rules that go along with the inequalities. But okay, maybe we'll leave that for a later question if that ever pops up. But for this one, since we have 0 already on one side, it becomes very easy We just have to maybe find some factors for this equation. And I think we can, yeah? So we have negative 10 and negative 3x. Let me start by rewriting the question. So we have x squared minus 3x minus 10 is greater than 0. Okay, so let's see. Okay, so we have a quadratic on the left hand side. Can we factor it? So we have negative 3 and negative 10. So what are the factors of 10? Of course, negative 10 itself, positive 10. The next one would be negative 5 and 5. The next one would be negative 2 and 2, and then negative 1 and positive 1. Yeah, those are the factors. So what if we take negative 5 plus 2? When we add these, we will get negative 3. And when we multiply them, we will get negative 10. Okay, good. So those are factors. So let's rewrite the expression. So x minus 5. Doesn't matter which one you put first or whatever. It's the same thing. Because multiplication is communicative. So whether you say 2 times 3 or 3 times 2, it is essentially the same thing. Yeah. Division, however, is not. I mean, if you say 2 divided by 3 and 3 divided by 2, you don't get the same answer. Just some interesting knowledge. Apologies, seems my system glitched out for a second. Okay, but I'm back. Okay. Okay. All right. Yeah, we're back. Okay, so we have that. Doesn't matter what order, as I was saying. Now we have enough to answer the question, really. So we can see here that well, if you draw this, you don't have to draw it, but if you draw it, you can see that so if we drew this function, it was a quadratic, so it was some function that looks like this. We can see that we're gonna have like positive 5 here as one of the roots and negative 2. Yeah, you can see that from here already. So we know that's what our function looks like. So how do we represent this on a number line? The equality is great. It's a greater than sign. It's not equal or less than. So if we were to put this on a number line, okay, we would have negative 2 here and an open circle, yeah, because it doesn't include negative 2 itself, and the function moving in that direction as positive. In between negative 2 and 5, we can see that the function is negative. It's below the x-axis, so this is negative. And then we'd have 5 here, and again an open circle. And the function, so the function increases when you go lower than negative 2, and it increases when you go above positive 5. But it decreases between those two. Okay, so rewriting that, we can say that x is less than negative 2 and x is greater than 5, yeah, in order to satisfy the fact that this quadratic is greater than 0. Okay, so yeah, in order for the quadratic to be greater than 0, i.e. above the x-axis, x must be less than -2 and greater than 5. Yeah, this side. So not this side. Yeah. Okay. So you definitely don't have to draw the graph. You can draw the number line as your final answer. That's acceptable, or just rewrite this here. And I hope that you can see that from this point, once we've factored, it is implied what the roots are. 5 and -2. Okay. All right. So yeah, these types of inequality questions require maybe a slightly bit more thinking, more visualization of what is being asked, but yeah, pretty much still the same thing. Okay, the fourth one. Okay, and now we see it's 4 marks, not just 3, so it's gonna be a bit trickier. So let's get into it. So 3 root x. Okay, and these are just multiplying each other. It's not the cube root of x. It's just 3 times the square root of x equals x minus 4. Okay. Okay. So often I wouldn't advise your first step to just square both sides. Especially when you're trying to solve for x. It's a bit counterintuitive to start squaring things because we're going to make the terms more complicated, but it's very difficult to do any work with this expression when we have the square root. So in this case, this is a rare case where the first thing we're going to do is just raise the left hand side and the right hand side of the equation to the power of 2. Now, it is important to note that you will not get a result of x squared plus 16 here. This is wrong. We are not squaring each term individually. We are squaring everything on the right hand side as one term and everything on the left hand side as one term. Okay. Yeah, so that is a trick that's a mistake that students often make, and then you'll end up with a wrong answer. So because these two are simply multiplying each other, we can just square each term as its own term. But these two are adding and subtracting, so we can't. We have to do the FOIL method or expanding the brackets, whatever you want to call it. But for here, we can just square each number individually. So 3 squared is 9. Square root of x squared is just x. Yeah, so we just get 9x there. This side, I find it easier just to imagine a second term, because it's essentially what you're doing, multiplying the same thing by itself twice. So x times x, x squared, x times minus 4x, minus 4x, minus 4 times x, minus 4x, minus 4 times minus 4, positive 16. Yeah, and then of course these two, we can just rewrite this as negative 8x plus 16. Okay. Now at this point, you can just also bring this x this side, and then we'll have some quadratic to 0, and then we can try and factor it and see if we can factor it and then solve it. Okay, so that's what we're going to do. So if we bring 9x the other side, let's just rewrite it with x squared this side. We bring it over, it becomes negative 9x. So we'll have negative 17x plus 16 equals 0. Okay, so we need to find factors of positive 16 that add or subtract to give negative 17. Okay, what are the factors of 16? So yeah, okay, we have 16 itself, 8, 4, 2, and 1. So what if we had negative 16 and positive 1? So if we add them, okay, if we multiply them, we're going to get negative 16, which is not what we have here. So can't use these. What if we make them both negative? Yeah. So negative 16 and negative 1. Of course, for these numbers, we also have the negatives as well. Yeah, those are also factors. So negative 16 and negative 1, if we multiply them, yes, we get 16. If we add them, yes, we get negative 17. So these are our factors. Okay, good. It's factorable. So we don't have to use the quadratic formula. We can just factor this. So it doesn't matter how you write it. But you will get this. And then, of course, x just equals 16 or x equals 1. Good. And that's good for 4 marks. Yeah. So, okay, there are a couple of a couple of other ways you could solve this. I don't think it's worth showing you. But yeah. Okay, I will just show it for interest's sake. Let me put this in blue. So in the beginning, I mean, we have 3 root x, which is the same as saying x to the half equals x minus 4. Yeah. So we rewrite it like this, and then we just shift the x term, this term, to the right hand side. We will get something like x minus 3x to the half minus 4 equals 0. Okay. And what you need to see here is that x, yeah, this is kind of hard. You need to recognize that x is the same as saying x to the half to the half. Yeah. That's really tricky. And then you can factor it. So yeah, you would have to rewrite this x like this, and then you can do a factorization. Yeah, you can do a factorization. So there's a bit of a trickier way of doing it. It is much shorter, I won't lie. Like, I mean, it's just like 3 or 4 steps to the answer, whereas here we have like 6. But it's kind of hard to see this. Most students won't see this. But if you can, then if you can see this quickly, it'll probably save you some time. But the first method we used is definitely the more robust one and the easier one, just a bit longer, more steps. Okay. Good. Okay, now we have a simultaneous equation worth 6 marks. Okay. So with simultaneous equations, there's 3 methods that you can use to solve them. Personally, I would recommend only choosing between 2 methods. The third method is, okay, so the methods are elimination, substitution, and then there's a graph method. The graph method, you know, you need graph paper and all of these other things often, and it's time consuming to try and plot these functions. Yeah. I wouldn't bother myself with the graph method. Maybe just know it exists, it's a thing, it's out there, but yeah. Often the elimination method is probably the easiest. It's the shortest method. Substitution is a bit of a longer method, but it's easier sometimes, depending on the expression. Sometimes the substitution method, it's just easier to do. Elimination method, what happens sometimes is it's difficult to try and cancel a term, okay? You basically need to cancel a term by adding or subtracting the two equations. That's the elimination method, and then you can solve for one term. So, I don't know. It's really personal preference. I think here, since it's a bit easier, we're just gonna do the substitution method. But there are another two methods you can do it. So let's just name the first equation equation 1, the second equation 2. So let's work with equation 1 for now. Let's make y the subject of the formula. Okay, so we have 3x minus y equals 2. We can subtract 3x both sides, so we'll have 2 minus 3x. And then we don't want negative y. Yeah, let's make it positive. So multiply both sides by negative 1, and we will have 3x minus 2. Okay. So now we know what y equals. Okay, so let's call this 3. Now we're going to substitute 3 into 2. Okay, so 3 into 2. Okay, so we have 2 subs in y, 3x minus 2 plus 9x squared equals negative 1. Okay, let's just get rid of everything in the bracket. So we have 6x minus 4 plus 1. So we'll just bring that aside in one step. Plus 9x squared equals 0. So 9x squared plus 6x minus 3 equals 0. Okay, and we have ourselves a quadratic. I think it's factorable. Let's see. So we have... it's not, because we have a 9. We have a 9x here. Okay. So let's just divide everything by 3, yeah? Let's do that. So we'll get 3x squared plus 2x minus 1 equals 0. Okay. Okay. Now we can factor, but we mustn't forget about this 3. Okay, so the factoring will be different to the factoring we've done previously. Okay, so we have 2 and negative 1. So I think the obvious one is negative 1 and positive 1, yeah? Those are the obvious factors to multiply to get 1. But when you add them, you won't get 2. Okay. So what factors can we use here? Negative 1 and 1 are the factors. I think this is one of those situations where you can just try. So this rule that I use over here, you don't always have to follow it, but you can just try. So if we try negative 1 and 1, I mean, we mustn't forget about this 3x. And then we're going to have x plus 1. Yeah, mustn't forget about that. Let's try and multiply this and see if we get back to that. So 3x squared plus 3x minus x minus 1. So 3x squared plus 2x minus 1. Okay, so we do get back to that, yeah? So sometimes you just have to see the factors. The method of multiplying to get this one and adding to get this one, it's a good method to follow, but it's not always the case. And I don't want to use the quadratic formula here because we'll end up wasting time and the question will be too long. So you just have to see, maybe try some factors like what I've done with -1 and +1. They're really the only factors that work because you're dealing with 1. There's no other numbers you can multiply together to get 1 aside from 1 itself. Yeah. So you need to see that. So then we can now factorize here. 3x, we'll say minus 1 and x plus 1. So here x equals 1 over 3 or x equals -1. Okay. So now that we know this, we need to take these values of x and figure out what the values of y are. Okay. So when x equals 1/3, 3 times 1/3 is just 1. 1 minus 2 is -1. Okay. And when x equals -1, so 3 times -1 is -3, minus 2 is -5. And these are the solutions to the simultaneous equation. Good for 6 marks. So tricky question. I guess the way we did it, factoring this can be difficult. Yeah, that's probably the hardest part of the question. But yeah, you can just try out some factors and see if they work. Sometimes trial and error. Luckily, you're dealing with small numbers, 2 and 1. There's only like maybe 2 or 3 different combinations of numbers you can use. So you won't spend that much time just trying out factors. Because you really don't want to start using the quadratic equation to do this. It's just going to take too much time and the question's only 6 marks. Yeah, it's already so long. But yeah, that's good for 6 marks. Good. Okay. Question 1.3 for 4 marks without a calculator. Interesting. Okay, if 3 to the power of 9x equals 64 and 5 to the power of root p equals 64, calculate without the use of a calculator the value of 3 to the power of x minus 1 cubed over the square root of 5 to the power of root p. Yeah, these questions, they just try to confuse you. The first step is just to figure out the values of x and p, which we can do. Okay. We can do. So let's rewrite the given information. So 3 to the power of 9x equals 64. And the other one is 5 to the power of root p equals 64 as well. Okay. So what number can we raise 3 to the power of to get 64? So you can just think, if you know your logarithms, you can solve this very easily using logarithms. Yeah, you can actually use your calculator to figure out what power to raise 3 to in order to get 64. Yeah, but yeah, it would be something like, I believe it would be log, shift log, base, we're dealing in base 3 and we want to get 64. Yeah. And it's not an even number. Wow. Okay, so let's think. So you can check with your calculator, hey? There should be a button on your calculator that looks something like this: log, and then like a little square here that's colored in, and then a big square that's not colored in. So if you want to figure out what number you need to raise 3 to the power of to get 64, you would say log, and then for the bottom number, base 3 to get 64. Yeah, you can use this to check. Do we get a whole number? Unfortunately, we don't, hey? Log base 3, 64. We get some funny number, 3.7, whatever. So this is not a whole number. So we can't use this method. Logs is pretty useless for us here. We wouldn't write that as a part of our answer. It's just like a little trick. I mean, we have our calculator with us. Maybe we can use it to help us. Okay, but of course they say don't use your calculator. So let's get a bit more creative. Now, what are the factors of 64? Well, 32, 16, 8, yeah, 4. 4 is a factor. Of those factors, are there any factors that we can raise to a power that's similar to 9x? That's a factor of 9 maybe. So is there maybe like, okay, so 3 is a factor of 9. Yeah? So is there some power of the factors of 64 that we can raise to the power 3 to get back 64? In other words, I'm asking, what is the cube root of 64? So 4 times 4 is 16. 16 times 4 is 64. So the cube root of 64 is 4. So you can rewrite 64 as 4 to the power 3. Okay. For some of these questions, yeah, you just gotta try and imagine, how can I rewrite the number, you know? So 64, we can rewrite it as 4 to the power 3. 3 to the power of 9x. Okay, so we must remember our rules of powers. We can rewrite this as well. So basically, we want to get the two terms to both be to the power 3. And then if the exponents are both to the power 3, we can then equate the bases to each other. That's the trick. And I think we're on the right track. So we can rewrite 3 to the power of 9x as 3 to the power of 3x to the power of 3. Yeah? Because an exponent raised to an exponent, you multiply them. So 3 times 3x gives us straight back to 9x. So these are the same thing. Yeah? This is a tricky question. So we've rewritten that, and we have this. So now we have two. The exponents are now the same. Yeah? Everything's to the power 3. That means we can equate the bases to be equal. So we can say 3 to the 3x equals 4. Okay. Yeah, I don't think we can do much work here. So let's just leave that for now. And let's apply a similar analysis with the second expression. Okay. With the second, okay, so yeah, let's remember we're trying to get to 3x minus 1 to the power 3 over root 5 root p. Okay. This is what we're trying to get to actually. Like, we don't actually care about x and p really. We just need to get this expression. Yeah. So I think, yeah, I mean, we've done quite about as much work as we can with 3 to the 9x for now. So in order to get this to look like this, maybe let's take square roots both sides. Yeah. Let's take the square root both sides. So if we take the square root both sides, we'll have root 5 to the power of root p equals the square root of 64, which is 8, I believe. Yeah, it's 8. Okay. All right. So root 5 to root p equals 8. Is this correct? Okay. I don't think we can do much work here as well. So maybe, okay, we've done as much work on this one. We've done as much work on this one. Can we do any work here? Yeah, I think we can. So we can multiply these exponents here. So we can rewrite this expression. This expression becomes 3 multiplying 3 times x minus 1. We will get 3x minus 1. And then, of course, this just stays the same. So root 5 to the power of root p. And yeah. Oh no, this is 3. 3x minus 3. Okay. So what can we do here? So okay, so we can do some work on top, yeah? So let's just focus on the top. We can rewrite this as 3 to the 3x multiplied by 3 to the power of negative 3. It's the same thing, yeah? I hope you see that. It's the same thing. And any negative power, we can just drop it below. So we can rewrite this as 3 to the 3x over 3 to the 3. And 3 to the 3 is just 27, yeah? It's just the same as 27. So with this in mind, we can rewrite our expression. So we'll just continue down here. We can say 3 to the 3x over 27 times root 5 to root p. Okay. Okay. And we know that 3 to the 3x equals 4. So we can just replace this and say this equals 4. Okay. So we have 4 over 27 times. And we know that root 5 to root p equals 8. Yeah. So we can replace this and say this equals 8. Yeah. And then we can solve. And this just gives us 1 over 54. Yeah. You can use your calculator for this last step, definitely. But yeah, so when you simplify it, you'll get something like 1 over 54. You don't want to like write this as a decimal though. Just use your calculator to say 27 times 8. You'll get 216 and then divide by 4 to get 1. So 216 divided by 4 is 54. So the fraction is just 1 over 54. And this is your final answer. This is a really tricky question. Yeah, lots of algebra. You're trying to manipulate terms because we can't solve this directly. So we're going to use the given information to try and get some values for root 5 of root p and 3x minus 1 to the power 3 to try and substitute in, which is what we did for 4 and 8 to solve. So yeah, really tricky question, good for 4 marks. These are the types of questions, I mean, it's a really difficult question and it's only 4 marks. So if you're struggling with it and you can't figure it out, these are the types of questions you should leave behind and circle back to, for sure. But yeah, I hope this has been useful and I'll see you in the next video.